It's a real pleasure to be here. Thank you to Oliver and the team for inviting me. Doing a talk is a great opportunity, but I'd also like to thank them for the air-conditioned hotel room that I stayed in last night. Sorry to rub that in. And also, my son wakes up at between 4:30 and 5 a.m. every morning, so being away from him, who I love very much, is great. I woke up at 6 this morning, and that was a massive lie-in. So, yeah, thank you for that. And that's me done. I don't really need to do the talk. That's all I'm here for. So yeah, my name's Jack. I work at Google on the Chrome developer tools, and specifically these days I focus a lot on web performance and our performance tooling. So that's the performance panel in DevTools, that's Lighthouse, a little bit of other things as well. I want to talk today about sort of demystifying web performance and trying to encourage you to kind of dive in, because it can be a very overwhelming topic. There are lots of different avenues to explore. The tools give you a lot of data and information on your page or your web app, which is great. But that also means that you have to figure out how to understand and deal with that data. And hopefully by the end of the day, you'll feel a little bit more encouraged to dive in and debug and figure out website performance issues. Now, as someone doing a talk on web performance, I'm pretty much legally obligated to give you case studies on why web performance is important. So here we go, here's a few. But at this point, it's very well known that if you increase your website's loading speed or its general performance, your users will spend more time on that website. If you're an e-commerce platform or you're trying to take money from them, they will probably spend more money if you make your site load better and faster and just be generally nicer to use. And so you can dive into all the stats on the links there, and I'll share the slides afterwards. It's also something that potentially performance we take for granted here in the UK. We're very fortunate to have, pretty powerful devices, particularly in this room full of designers and developers and people generally in the sort of tech space. We have very powerful devices that can deal with a lot of code. And generally, if we're sat in the office, we're on pretty quick Wi-Fi. Of course, that's not true for everyone in the world. Connectivity is very different in different parts of the world. So depending on where your users are, your experience in your office or even on a 4G or 5G connection in Bristol is going to be very different. But then when you sort of talk about this, I think some people are like, well, all our users are based in the UK or the US, and so generally this isn't a problem. But I imagine that all of us actually have connectivity issues on a pretty daily basis. So a few years ago, we did the classic COVID thing of leaving a tiny flat in London for the Surrey suburbs to get a little bit of green space. And this is my commute that I do to the office, thankfully not too often. So it's just over an hour on the train. It's quite a long commute into the work, relatively. And when we were moving down here, my wife and I said, well, what we could do is we could work on the train to and from the office. So some days we could get back a bit earlier to kind of minimize the impact of the commute by working on the train. So you can go into the office, then leave a bit earlier, work for an hour. So worker happy, you get home at sort of 5, 6 p.m. rather than 7, 8 p.m. That was a really good plan if the internet or the mobile data even worked halfway along this route. And bear in mind, this is London to Surrey. This is like, this is supposedly the privileged part of the country. And this should work well, but it really doesn't. I enter a massive tunnel around here, and then I have what I call Li-Fi, where the phone thinks it has 4G, but it does not, trust me. There's just no signal here going through Croydon, which is actually, quite a big populated area. There should be signal. There just is none. I don't know why. And then obviously, as you approach London, you go underground, and then all hope is lost. Not just because you're approaching London, just to be clear. And so, yeah, so at Google, we have a lot of internal tools that I need to rely on. These tools are built for people sat in a Google office with quick internet. They are completely unusable on this train journey. So if I do have to do any work on the train, I have to get it all offline on my laptop before I leave home or the office, and then only work offline, because even the bits between those red lines, we're talking spotty at best. So I have, an M1 Mega Pro Max silicon chip, whatever, and I live in the UK, and I'm still affected every single day I go into the office by connectivity. But there's also lots of other contexts where I have to be more careful about data. Whenever we go abroad now, I would buy an eSIM for whatever country I'm visiting. And this really brings it in perspective that now you're in a situation where you're paying for data. In this case, of course, a gigabyte for £3.50 is not a huge stretch. I think most people in this room could manage that. But there are other countries you might buy SIMs for where the data is more expensive, or there are other people who, for the money here, is more challenging. And it's very interesting to go and buy one of these and think, oh, a gigabyte will be fine for 7 days, and then watch the app as it ticks up and up over time. And you suddenly become very sensitive to performance and heavy sites. But these days, with the web being such a platform that is really everywhere in our lives, we're not even just talking about the traditional loading and website performance anymore. A lot of you may or may not know that if you've got a sort of fairly modern TV, LG definitely, I think Sony and others as well, that when you're using these, that you're actually running the web. LG TVs run off WebOS, which is a Chromium-based operating system. And so your TV is running Chrome as well, effectively. And so recently there was this case study where Disney, on living room devices, aka I guess TVs, reduced their INP, which is sort of a measure of interactivity on a website, how quickly it responds to user interaction. They reduced that by 61% and doubled their weekly card views, usage of their application. And we'll dive into it, but the screenshots there are actually the DevTools performance panel. So this is people debugging the TV operating system using developer tools because it's built on the web. So really, you can't really avoid this stuff. And performance, in whatever sense you look at it, the web plays a big part of that. But really, hopefully I don't need to convince you that performance is important because it's just nice when a site feels nice. I think we all probably have tasks we do like admin, chores, whatever, or ordering or shopping or buying something. Sometimes that's a nice experience because the website's good, it's snappy, it loads quickly. Other times you dread going to this particular website or using a certain app because you just know it's going to be a pain. There's one where we order, what do we order? Our coffee from, and it will ask me to change my address 3 or 4 times, and it just repeats it. And after the 4th time, it lets you check out, and I don't know why. And so I hate it. I hate it, and I want to find somewhere else. But if that site felt nice, I would probably buy more coffee. And so that's why I want to talk about debugging web performance. I also think even if there are some of you who might not be debugging websites on the regular for performance reasons, if you ever use any performance tooling for whatever it may be, maybe some of you might build like games in your spare time or build other software, most performance profiling tools share a lot in common. So even if this isn't maybe something you're going to do on a daily basis in your work, if you ever got a side project or something, you may well find a lot of what I talk about very applicable, even if you're moving out of the web world. So to demonstrate this, I built a website that we're going to debug together. It's called Pixel Pioneers. It's bad, it's bad. And I just want to show you how slowly this loads. Now, bear in mind, this is on my laptop, so a pretty chunky laptop. This is running locally on my machine, so I'm not relying on a Wi-Fi or a connection or anything else. And so this is it loading. So it's not good. Bear in mind that this is, local. This should be very snappy. I'll be honest, it's a slightly contrived website to help me prove a point and look really smart in front of you all. But generally, this sort of thing is pretty representative of what you can get. So I work on Chrome developer tools, and so what I want to do is take you on the journey for how I would sort of begin to debug this, assuming I hadn't built this website, I was asked to look at it, maybe it's a client's website. So the first thing I'm going to do is pop open DevTools. By the way, the only acceptable places to have DevTools are on the bottom or on the right. If you have it on the left, you're gone, you're useless, you're dead to me. The stats bear that out as well. It's something like, I can't know what it is, but it's a very few people have it on the left, and for good reason. You're a maniac. So the right is fine, that's acceptable. You can also undock it as well, I'll allow that. But left is, no, forget it. And so when you load this up now, you'll see a fairly recent change. You get actually live metrics shown to you based on your interactions. Before, you used to always have to hit record to get data. You don't anymore, you get some stuff up front. And it's this that we're going to look at, the largest contentful pane, or LCP for short. So the LCP is an important metric for measuring what we call perceived load speed. And I've sort of highlighted perceived there because I think it's really important that we have these metrics to try and measure performance. But at the end of the day, they can only try to be a representation of what your users are seeing. It's very hard to pin down a number or a point in time where we call a website done or loaded or good or bad. So these metrics are just perceived load speed, what your users feel like. And also, I'll also call out that in this quote, it says has likely loaded. You always have to apply a little bit of kind of context in the website you're working with in particular. So what I do at this point is I'm going to hit the little reload and record icon. I click that, and it sort of refreshes the website and does a performance trace for me. And then we get something that looks a bit like this. Now, at this point, having it on the right-hand side squashed is going to be a bit of a challenge. So at this point, I will accept that we have to undock into its own window. And then you're going to get something that looks like this. And for some of you in the room, I've seen Andy Davis sat somewhere towards the front row. He will look at this, and this is what he puts on his telly in the evening to relax. This is what he does. But for a lot of you who maybe haven't, your first reaction will be more along the lines of, oh my goodness, what am I looking at? A lot of people see this and they see a lot of information, there's a lot of data, and it can be very overwhelming to even know where to look. I think that's a perfectly reasonable and rational response to seeing this. But the good news is that performance tools, like in this case, the DevTools performance panel, they're showing you as much data as we can possibly show you because we don't know exactly what it is you're trying to debug. We just want to throw you all the information, to let you make sense of what you need to make sense of. And so whenever you're using these tools, it's important to remember what you're trying to solve. Pick one thing at a time that you want to explore. Don't worry about looking at it and finding every single possible problem that you could ever find. DevTools is only ever going to show you or try and highlight things that it thinks are problems, but remember that it doesn't know the exact architecture of your site, it doesn't know your users, it doesn't know a lot of the context. So you need to work with DevTools, but then apply your own layer of thinking on top of it. And never assume that what DevTools tells you is completely accurate or right. It may be slightly different. You might need to do something slightly different just because of how your site is built or operates. And so what we're going to do here is at the top of the page, we have what we call the overview or the mini-map. This shows you a sort of glimpse of your entire trace. And you can just see below the sort of big yellow chunks, there are very small screenshots of the page. You can track over time what the user saw. If we hover over this, we can see the screenshots bigger. So this screenshot is actually the point in time where the LCP has happened. And this is because the browser has identified the big navy blue rectangle here as being the largest element that is painted. So this is our approximation of the page being loaded. But if you are a human, which you are, and you look at this, you probably think there's some crucial information missing on this page, namely that there's not a single word of text on there. And I don't know about you, but I would not consider this page loaded. I don't think I could really achieve much looking at just the images. If we go along a little bit further in the timeline, then the text pops in. So this is a good example of where my largest contentful paint was slightly earlier with the image. But in this case, what I really want to optimize is what point do we get the images and the text onto the screen? Because really, until we have the text, we don't have anything. If anything, I'd rather the text came way before the images, so at least the user can start reading it. And so to deal with the sort of overwhelming amount of data, what I can do is I can drag these handles at the top and sort of scope the performance panel down to just a little point in time. So I zoom in, and now I've discarded every bit of data that's outside that time range I want to investigate. And so now at this point, it's time to go hunting for clues. And what we're looking for is space where the browser could be doing something and isn't doing something, or is doing something completely not useful that we don't want it to be doing. So I always look for dead chunks of time. So at the top here, just below the mini-map, we have the network track. That shows you all the network requests when they started and happened. And down the bottom, below the bigger screenshots, we have the main thread. And this is the JavaScript that was running, that the browser was running at this point in time. And so if I look at this area is calling me. It's suspicious. It's suspicious because, as you can see at this point, we haven't actually shown anything to the user. The user is still seeing a blank white page at this point. But as we can see, the main thread, is running an awful amount of JavaScript. There's this big chunk of JavaScript, and we'll dive more into what this looks like later on. And this feels weird to me because we're running all this JavaScript before we've even shown the user anything on our page. This feels like an opportunity to improve the situation. And if you can vertically track your eyes up and down to look at what else happened around this time, and we can actually see there's a JavaScript file there called heavyprocessing.js. I told you it was contrived. And when that is done loading, we then kick off this big chunk of JavaScript. And so that seems to me suspicious. Of course, I have the benefit of having called it heavyprocessing.js. Yours would probably be like app.js or whatever it may be. And then we can see that things start happening again once this big chunk of JavaScript is done. And so this is a case where we need to look at optimizing what the browser is doing. And browsers are single-threaded. That means that, with some caveats and details that are boring and I won't go into, most of the time the browser can only do one thing at once. If you've got some JavaScript and it's running some JavaScript, that's it. That's going to keep it busy. It can't even draw or give an update on the screen. So when we fetch this file and then we execute it, that's it. That's all it's doing. It can't do anything to stop and paint, as in draw the new update to the user. And that's what it really wants to do. So the more time you keep the browser busy doing JavaScript, the less time it's got to pause and do other bits of work, like show the user the next update or paint what we call the next frame, literally draw the pixels for the user. So we can see that kind of happening here. We fetch the JavaScript and we execute it. And then only once the JavaScript stops, we give the browser a chance to paint. And then at that point, it draws something onto the user. So if we could get rid of this big chunk of JavaScript down the bottom, we'd allow the browser to paint much earlier, which would show something to the user much earlier. I'm also going to take this opportunity to show off a fairly new DevTools feature. On these things, you can double-click, and you can actually add labels for yourself. So if you double-click on something and type something in, you can leave yourself notes, which can be very happy if you're trying to track over time what's going on here. We can all watch me make a couple of typos now because I'm not good at editing screencasts. Yeah, there's one, and there's the next one. Great. But this is a very useful feature, I find, in terms of leaving yourself notes as you're debugging and investigating. You can also export this trace with these notes and send it to a colleague if you want their opinion as well. And I could spend multiple hours talking about browsers and how they render and main threads and stuff. And Oliver told me I can't. But if you do want to do more about this or learn more about this, a guy called Jake Archibald, who I'm sure a lot of you have come across on the internet or seen at conferences, he did a great talk about the web browser event loop and how this all works. So I'd really recommend giving that a watch. So we found our first issue. Heavy processing.js is blocking the main thread, which is slowing us down. That's not the only thing, though, that I think we can explore here. So we go back to our trace. And again, I'm looking for dead time. And you can see the same kind of pattern happens again over here with this red box here. Nothing is happening. We have some JavaScript down the bottom. But what we also have is our font. This font, Roboto Bold, this is actually the font that we use on the page. This is the text. And so firstly, for me, this is odd that we're loading this font so late on, when this is the main font for the body text. And we also have another huge chunk of JavaScript that's happening here. I also don't know if you can make it out of the back, but this heavy JavaScript, it says event DOM content loaded. So this is like an event listener that's firing, triggering off a bunch of code. And we'll come back to that later on. And only after that big JavaScript happens and we fetch the font do we then render the text. So we now found why we don't see the text for so long is because our page's font is loaded very late on. And if we look at why that is, if we dig into the network request, so I've just clicked on the Roboto Bold network request at the top, and we can see down here you get some more information about it. And if we zoom in, there's a few bits of interest, I should say, that we can look at here. The first is that this network request was initiated by our CSS. What that means is the browser has had to load in our style sheet and go through it to find the reference to this particular font before it can then request the font. So that feels to me like an opportunity for speed up. We've got main.css sort of in the way, if you like, of us loading in our font. And the second thing is on the right-hand side, we have sort of a breakdown of the duration. And here the request sent and waiting is 600 milliseconds, just over. This means at this point, this is the server taking a long time to respond. You've sent the request off, and now it's in the server's hands. How quickly can it come back? So here, this tells me that our server is taking over half a second to give us one font file, which to me sounds like an opportunity on our server side to do some optimization as well. So we now actually have a couple more issues we can add. Our page's font is discovered very late via our CSS file, and our server's response time seems pretty poor as well. One of the things you may have seen in one of the previous screenshots was this little insight box that popped up when I looked at the network request. And you might have also seen in a screenshot this insight sidebar. This is a relatively new addition to the performance panel, which shows you a bunch of information and insights on your performance and suggestions for how you could improve it. For those of you who have used Lighthouse, this might seem sort of vaguely familiar and linked nicely to Lighthouse audits. I'm going to take this opportunity to call out that they are very linked. They're going to be the same thing by the end of this year. People love using Lighthouse and getting the audits and a list of things. What we're trying to do is reconcile that and make it consistent across our tooling. So this set that's in the performance panel will also begin to appear in Lighthouse. There's a link if you want to know more about that. And these insights are really useful if you dig into them. So the network dependency tree insight looks at our chain of network requests. And if I click on this, you can see that it clearly shows me that we took 3.8 seconds to load the font. And it shows me that that came via styles main.css. So all that looking through the trace I did to figure that out, I could have clicked on the insight and done it straight away. If we also click on this insight, which is called LCP by phase, I appreciate it's quite small text. This breaks down the time spent in different phases to get that image painted onto the screen. And it shows us two really interesting things here by overlaying onto the timeline. It shows us that the time to first byte, e.g. when did the server send data back, was over a second. That's, again, another sign that our server has room to optimize here. And it shows that our render delay was very busy. That means we had the image ready to render, but the browser was busy with our JavaScript, so we couldn't do it. And so actually, I'm going to change issue 4 from our server's response time to serve the font is poor to just our server's response time is poor. So now we've found a few issues. It's time to actually dive in and try and fix them. We could spend a lot more time trying to find every single issue, but at this point, I'm pretty confident we found a few things that are worth looking at. So this suspiciously named script blocks the main thread. So this script is loaded in the head of our page as just a regular old script tag. And just, the obvious answer here, by the way, is just delete it. That would improve our performance greatly. I'm not going to stand here and tell you all to delete all your JavaScript to make your page load quicker. We have to be slightly practical about these things. So we're going to imagine that we can't do this. This is obviously stuff that has to be on the page. What we're trying to do is just say that we don't need to run it straight away. And there's a couple of different ways we could do this. We can move it down to the bottom of our document. But again, to sort of limit ourselves, I'm pretending we use some content management system or we're constrained in some way. Because performance is all about working within the constraints that you have to deal with. But luckily, there are a couple of attributes on script tags we can look at. So in this diagram, the green line is sort of the browser parsing our page. This is important. We don't want to disturb this because this lets the browser go through all the HTML and really get things onto the screen. A regular script tag, as you can see, pauses to fetch the script from the network and then pauses again, the red line, to run that script. But if you look at the defer tag, you can see it can fetch the script in parallel, sort of in the background. And then once it's done parsing, we can then execute the script. So if your script doesn't need to run straight away, you can throw a defer tag on it, just like this. And that immediately on its own makes a huge difference. Notice now that the font is loading a bit earlier. The heavy JavaScript is sort of in line with the first paint. It's not before that first paint. And we actually already bring our LCP down from, what was it, 3 point something, down to 1.71. So yes, performance can be complicated, and you can get real tricky cases of figuring out what's going on. But often there are fairly straightforward wins you can apply that will make it better. I think it's also important to note at this point that we could pause now, and this is still great. This is a humongous improvement. It's not necessarily always about squeezing every drop of performance out. I used to work at a lot of very small startups, but getting the time from the business or from product to invest in performance can often be a challenge. And so, if you can just spend half an hour to look at, can we add a defer tag or move a script, then that's a huge win already. It's not about squeezing every single dropout. It's about being realistic to the constraints and environment you work in. So that's already really good, but we can also see we still have this big chunk here. There's still opportunity here to bring these screenshots closer together. So if we look at this, we can see our font being loaded at the top. And to the right of the box where the font loads, there's this big line, which I would call a whisker in sort of tooling terms. So this where the red underline is there. And if we look at the timings for this network request, this shows that we're waiting on main thread. What this means is that the browser was busy running some JavaScript, so although it had the font ready to go, it didn't get an opportunity to redraw the page with that font applied. So we've got the font, it's ready, and then we delayed it by 1.3 seconds just so we could run some of our JavaScript. And so to understand how this works, what we need to do is dive a little bit more into the flame chart, which is that main thread activity box towards the bottom of the performance panel. These can seem very overwhelming and very complicated, but all they're doing is over time showing you what JavaScript was running on your page. So we have this code to plan a holiday, book a hotel, and book trains. Our flame chart is going to show us over time what functions ran and how long they took to run. So for this, we call plan holiday. Plan holiday then calls this book hotel function. Book hotel does two functions, actually. First, it calculates the number of nights, and then we book that number of nights. And then finally, we book our trains as well. So that, on the right-hand side, is a flame chart, and it shows you the representation of what happened over time. And also, you can see how long the functions took and why they took so long. So we can understand that plan holiday took that chunk of time because it was made up of both book hotel and book trains and so on. So all we're doing here is we're showing you over time how long functions took to run, just to help you spot opportunities to improve them. One small caveat that can be confusing is the Chrome profiler is what's called a sampling profiler. What that means is because it's very expensive to do performance tracing in instrument pages, we take a snapshot every interval. I think it's a few milliseconds, maybe 1 millisecond. So your program's running, and we go, bam, we're going to sample. And then bam, 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 bam. I don't know why I did the bams. I didn't practice with the bams. So we're taking snapshots at points in time. This means we don't have the history of every single function that ran over your entire application. We take various snapshots, and then we try to stitch that data back together. That means sometimes that we can get it slightly wrong or slightly misrepresent it. So here's what the code that actually ran. But depending on when we take those snapshots, we might mistakenly think that plan holiday was called twice, really close together, whereas actually it would be once. So again, with these tools, it's very hard to get 100% accurate data. So you always, again, have to apply a bit of nuance. If you know in your code that you only call plan holiday once, then we know the bottom flame chart is a lie, and we know that that's one big function call. So again, you have to be aware of what your code is doing and just bear that in mind. So going back to this and this big empty chunk, one of the ways we can actually sort of begin to get an understanding of what this work is using AI. Or as Leonie put it, we can ask the AI, I think, to toddle off, which I quite enjoyed. So we can right-click on something. I'm going to ask the AI here, I'm just going to ask it, what functions are being called here? And it actually does a pretty good job of diving through the flame chart and pulling out the names of the functions and how much time they took. So for this kind of thing, it's integrated into the panel. It's a really useful way to quickly digest a lot of information, which generally I find AI is pretty good at doing on the whole. And with JavaScript on your page that you're trying to deal with, there are always two questions. Do we need it at all? And if not, or if we do rather, do we need it now? Because it would be a pretty, not a great talk if I just said delete your JavaScript and walked off stage. I'm not Alex Russell. But what we can do is ask if we need it now, or can we defer it slightly? And so if we dive into our JavaScript, it's got this code. Obviously, it's completely contrived nonsense code for the sake of my talk. But let's imagine this, I don't know, this is analytics, or it's ads, or it's something that you need to run, but not necessarily delay everything. And there are various APIs we can use just to defer this work to later on. So I can wrap this in a bit of, in a callback to request idle callback, which literally just tells the browser like, hey, when you get a sec, could you run this for me? You can also give it a timeout if you need to make sure it happens by a particular time. But by doing this, we just make sure that it will happen, but at the browser's convenience, not ours. And if we do that, we can now suddenly see that the gap here is getting much shorter. We still have some JavaScript to deal with, which we will deal with. But notice the Roboto Bold font loading, the whisker is now much shorter. We're not blocking it as much, just by wrapping it in a request idle callback. We're still running the expensive JavaScript, but we just delayed it for a little bit. So that's that one done. Looking at the page's font and how it's loaded very late on, we saw here that the font is loaded via our CSS file. Ideally, we'd like the browser to know about the font as soon as possible so it can load it very quickly. So we can look at this chain here. So we load in the local host, that's the index page. Then we load the CSS, then we load the font. And really, this ends up being a little bit like a sort of waterfall effect. And as our friends TLC once said, don't go chasing waterfalls. I'm not going to sing it. No, I couldn't resist that one, but I won't sing until the party. But it would be much nicer if we could load these two in parallel at the same time, rather than wait for our CSS to load in. And there are many different ways to accomplish this. I don't have time to go into the nuances of all of them. But again, this can be a pretty straightforward fix. You can dump a preload tag into your HTML, and this effectively tells the browser, like, hey, you don't know you need this yet, but trust me, you're going to need this. So could you just load it as soon as possible? And by doing that, and we look at the network now, we can see that our font is loaded in parallel with our CSS, and now we're able to paint much more quickly. And the time between not having text has reduced significantly as well. I should say there are clearly more issues here. There are other opportunities to optimize this, but this is a really good first step in the right direction. But as you can see, we still have this DOM content loaded heavy bit of JavaScript that's running. So the developer here, aka me, has tried to be good. He's tried to wrap his code in a DOM content loaded listener to delay that JavaScript until the DOM is loaded. So the intention there is positive. However, DOM content loaded in this case isn't quite what we need. So DOM content loaded fires when the document has been parsed, but it doesn't necessarily wait for other things like images and so on to be loaded. There is another event called the load event, which fires when the whole page has loaded. So if I swap to using the load event, what we now see is all that JavaScript is deferred to over here, and crucially, it's deferred to after we've got text onto the screen. So now this is in a much better position, and we're putting this text in front of the user very, very quickly. Now, I would still, if this were me, I'd still want to do work to break this JavaScript up, look at if we need it all, can we optimize it, and so on. But at least now we've done it after we've put the page in front of the user. Again, it's not necessarily about getting every single drop of performance and making it absolutely perfect. It's about doing what you can, and this is already a huge improvement from where we started. I also want to just quickly take an opportunity to highlight a sort of lesser-known tool of DevTools that I think is very important. So CSS files are render blocking, so they stop the browser painting and parsing whilst the CSS is fetched and applied. And in this case, our CSS file is pretty chunky. And what we can actually do is use the coverage tool in DevTools to see how much of it is used. So I go into More Tools, Coverage, and reload the page. And it's going to tell me for my CSS and JavaScript how much of that page is actually, or how much of that code, rather, is actually used based on what we've painted to the screen. So you can see in this case, it's something like 92% of our CSS is not used on the initial page load. So I'm not going to dive into how we fix this now, but this is a real good opportunity to take the bit that is used, maybe put that inline in the page, load the rest, delay it, or optimize it. This is showing you a really good avenue to explore. You're putting a lot of code onto the user that isn't actually being exercised. And so with that, I'm going to call that we've kind of solved these two things. Finally, I want to have a quick look at server response time. A lot of us look at the front-end performance, but we forget that if we can optimize the server, that's a big part of the experience as well. I'll caveat this with, depending on what you work on, you may or may not have control of the server. So it might be in your case, you can't do anything here, you just have to accept it, and that's how it is. But if you can, I think there's a couple of tips that you can look at. The first, and you wouldn't have noticed this from any of the videos so far, is that our page actually does a few redirects before it lands us on the home page. If you visit the page and use the record and reload button in DevTools, you won't see these redirects because it will just reload the last page. So a handy tip if you ever want to check about redirects or really test your site from start to finish is navigate to about blank, then hit record, and then type in and go to your URL. And this is going to give you sort of the full experience of everything and capture as much information as we can. And we don't need to wait for that. If we do that and we look at another insight, the document request latency, you can see it tells us we had 3 redirects before we actually got to the page where we're now viewing that page. We can see that the server responded slowly. It's also identified that we're not compressing any of our assets as well. So this is a really good way to start digging into the server side as well. I'll also call out, before I run out of time, other insights that I think are useful here to look at optimizing that I haven't even touched upon so far. So we have cache lifetimes. So this can identify if you could be serving assets with better cache times, such that the browser can cache them on subsequent visits. And also image optimizations. We didn't even get to the fact that the main image that's painted is 3.6 megabytes, and I think about 4,000 pixels wide. So there's plenty of opportunity here, and the insights are a really good way to go through and look for areas where you could make some quick wins. This is a pretty quick win to take that hero article, resize it, reformat it, optimize it, dump it on your page. It's low effort and pretty big reward. And so with that, we can start to fix our response time as well. And so we've made a huge improvement to that page now. Is it perfect? No. Do we still have JavaScript we'd like to optimize? Yes. But is the LCP down from 3 point something to, I think, less than 2 or like 1 point something? Yeah, and that's great. If we could then control and optimize the server, we could probably bring that down a lot more as well. But I do want to touch briefly upon debugging interactions, because it's important to remember that loading the page is really only the first step, particularly if you have a web sort of single page application where users aren't refreshing the actual page a lot. These are very long-lived websites, and they can come with their own performance challenges. So Chrome data shows something like 90% of users' time is spent after it loads. So it's important that the interactions are snappy. I think we've all had an experience that looks like this, where you're clicking, and it's like there's a random delay, or it feels janky. So maybe you click again, but then it all fires, so you open and close it really rapidly. Or I've done this where I've clicked and the checkout button has moved, or I've added something to the cart incorrectly. It's a nightmare, and these things are incredibly frustrating. And generally, I think in the past, we focused a lot on load performance and less so on this side of it. So you can kind of get information at these from the DevTools as well. If you hit record and perform those interactions, you're going to get that data available to you. And so I won't dive into detail, but just very briefly, you'll see these interactions here. Now, the guidance from Chrome is that these should be no more than 200 milliseconds in length. That's still a long time. Obviously, we're aiming for much lower than that. But that's kind of the upper bar. And if we use the INP by phase insight, which splits apart this interaction into its 3 kind of smaller parts, that will kind of highlight what the slowest interaction was on the page and give you information on which part of it was problematic. And the link to the web dev docs will give you a lot more information on this. I've got to kind of squeeze it in. But then if you, again, scan vertically down and look at the main thread activity, you'll see that when we did this, we have this function call that seems problematic. If you click into that function call, it will then take you to the right line of code in your code base where that happened. And now we can begin to optimize that click event as well. Interactions are often about what happened on the main thread, like why was the browser unable to give the user a visual update and paint. And so being able to debug the main thread activity is very important for this side of things. Finally, I also want to touch on reproducing what your users see, because this is something that's very easy to not think about and just not really end up with a reliable reproduction. Most of us have probably in this room have a pretty powerful device, especially if our company buys it and they're nice and they buy you high-powered things. We're probably on pretty speedy computers on pretty speedy Wi-Fi a lot of the time. The problem with that is then reproducing in DevTools the issues your users are seeing, it can be a challenge. There are various tools available to you to see real-world user data for your website. So this is Page Speed Insights. So I put the Pixel Pioneers website in. Good news, Oliver, you're in the green. So well done. Although we won't touch upon the 72 orange score down there, but I'll tell you my fees later on. But you can see here what real users are seeing on your website, and there's a bunch more information here you can dig into as well. You can also compare mobile and desktop too. And there's, in my experience, three things that are really important to at least try and approximate when you're trying to reproduce a performance issue. What screen size? Are you mostly mobile or desktop or somewhere in between? What device, as in how powerful on average is the device that that your users are most often using? And then finally, what on average network connections do they have? Because then if we do that, we can try to recreate these issues on your machine and really try and get a representative sort of reproduction of them. Now, I'll caveat this by saying you can never reliably 100% recreate a user on their phone, on a train, or in a spotty connection. The emulation tools are never going to get you to that exact scenario. Ideally, you would have those physical devices and you could go to places with connectivity and you could test there. But often we need to do it from a machine, so we have to kind of do our best to at least be representative. And so we've been working on pulling in this field data into DevTools. So I've gone to the Pixel Pioneers website. And on the right-hand side, you can see I can set up field metrics. What this is going to do is it's going to pull in the data that we were just looking at from PageSpeed Insights into the developer tools. The reason that's really useful is because you can see now that we have two numbers on this view. And we can see our local number on the left, so that's what the number was on my machine. And then on the right, we have what it is in the fields. This is what your actual users are seeing. And why this is useful is because it tells me that, well, locally, I'm seeing a much better experience than the average user does. So if I'm trying to reproduce a performance problem, I'm not going to have much success if I stick with this because my numbers are just way better because I'm on, I don't know, a more powerful machine, better internet. But what you can then do in DevTools is go into the environment settings on the performance panel and try and change the CPU and network throttling to at least get closer to what your users are seeing. And if you bring in field data, we will try to suggest this, depending on how popular, bluntly, your website is and how much data we have. The suggestions may be more or less accurate. So it tells me that I should set my network to fast 4G, so I'll do that. And then CPU throttling, you can throttle your CPU by a certain amount. You can also go through a calibration process where we'll try and throttle your laptop based on how powerful it is relative to sort of lower-end mobile device. That's a fairly new thing that shipped quite recently. If I do that, and I think I go low-tier mobile here, you can see that I'm now better. My local is 0.86, so I've gone up. So I'm already closer to what my users see. But then I can play with this some more. I actually swapped to 20 times slowdown on the CPU, and I swapped from fast 4G to slow 4G. And now at this point, you can see that my local number is actually worse than it is in the field. So now if there's a particular load problem I'm trying to reproduce and debug, I'm in a much better position to at least get closer to that issue. So it's really important to think about this before you start diving in. And one final tip that I'll mention sort of as a bonus at the end, as you may have noticed on all my slides down the bottom, we have this set of first and third parties. This shows you all the different origins where scripts and whatever resources came from for your website. And you can see I've got a number that say extension. A lot of these are actually Google internal extensions, so I probably shouldn't have put them on the slide, but there we go, it's too late. But the problem with extensions is they can drastically impact your page. You can see the second one, the LLM extension, we're good at naming things, has a main thread time of over 2 seconds. That's a lot of time that I've got on in my performance trace that's taken up by an extension that I'm pretty sure none of you have here in this room. And so often, one good tip is that incognito mode can be really powerful for figuring out, or rather removing extensions from your page. So if I run in incognito mode, sadly I still get one extension that has to be on, I can't disable it. But you can see the rest are gone now. So if you're running with a lot of extensions locally or particularly heavy or intensive extensions, this can be a good way to get rid of those. Although often I have heard of people deliberately running with extensions because it emulates pages. I think like 1Password at one point had a big performance problem, so it was actually very useful to have that installed so you could replicate that on your site. So with that, I'll try and wrap up with a sort of summary of things that I want you to take away and think about when you're applying this to your own sites and applications. So just remember what problems you're trying to solve. DevTools is there to give you as much information as possible. You need to pick and choose the bits that are going to be relevant to what you're solving. Look for the potential problems that DevTools is showing you. It will show you a lot. Again, filter that down to what you need. And each one needs some verification. Look at it carefully. Think about if it applies to your website. The fix that might be most common might not apply to your site. You might have a different constraint. Your content management system doesn't flex in the way we would need it to. So then you can try and think about how to apply that to your environment. And make sure your environment is as accurate as it can be by trying to emulate throttling and so on. Apply your own wisdom and knowledge. Performance is full of nuance. It's very hard to pin, this is the load time, this is this is this. You have to really take those numbers as a guide and apply your own context to it. And finally, you can make trade-offs and you don't have to fix everything. This isn't a case of trying to get rid of every single performance problem on your site. It's not a case of trying to rebuild your whole app in a weekend to get rid of some problematic script. It's not a case of convincing marketing that you need to get rid of every ad on the page. But try and do what you can with what's available to you. And with that, with 3 seconds left, I'll say thank you very much for listening. Please come and grab me later on, and thanks for your time.